Okay, so in this equation, I'm gonna explain on question number 12. So first thing that you need to do is actually sketch the diagram, label everything, the information that it gave you. So in this case, it give you an object. It's launched with an angle 25 from the roof of a building with an initial velocity u 42 meter per second on a building of height 50 meter. So those are the information that it gave you. So from here, you should right away write down all information that you know that you can obtain from the values here. So you can get u, x and uy. Okay, so ux is cos, uy is sine, because this 25 is on the horizontal, which is adjacent. Okay. Next, for part A, it asks you the maximum height from the ground. So it asks you to find this height from the ground to the maximum height that it reached after it's being projected. Okay, so in order to do so, we already have information regarding the height of the building. Therefore, the only bit of information that we need to find is this part, which is I'm going to label SY here. So in order to find the maximum height, you need to add the height of the building plus SY here. So you need to find SY. How are you going to find SY? By doing SUVAT analysis. I'm going to call it SUVAT analysis because SUVAT are all the physical quantities related to this projectile motion. Okay, so SY is what we're going to find. UY we have. VY 0. Okay, Y 0 I'm going to explain. Okay, at maximum point you should know that Vy is always equals to 0. Why? Because as the object goes up to maximum, at that particular maximum point is where it turns its direction. Therefore, at that particular point is when the velocity is 0. But it's not the total V is equal to 0, only the Y component is equal to 0. Okay? Because it's going down. Vx will always remain constant. So it will always equal to the initial part, which is ux. Ux here will be equal to here, V equals. Okay? So remember this part. So we have Vy equals to 0. So Ay will always equals to negative 9.81 meter per second, and you don't have any information regarding time. Therefore, based from this SUVAT analysis, please choose the most suitable equation. Okay, you want to find S, so therefore choose the one with S. Second and third one has S, but you don't have time. Therefore, please don't use the third one. Use the second one. Okay, so V squared U squared plus 2AS. But please remember, for projectile motion, you need to label whether you are doing X or Y component. Okay, you are trying to find Y, SY, therefore all component here, all vectors here need to be labeled with Y. Okay, VY, UY, AY, SY. So you have VY equals to 0, UY is this one, AY is negative 9.81, SY is what we're going to find. So rearrange, you get SY equals to 16.06 meter. But this is not the end, because it asks you to find the maximum height. Therefore, your SY, you need to add with the height of the building. Therefore, you get the answer 66.06 meter. Okay. Part B, it asks you when will it reach its maximum height. When, meaning it asks for time, but not the total time for it to reach the ground, but the total for it to reach maximum height. So it asks you for the time from here to here. So the things that you need to consider is only at those parts. Okay, the information that you have is the height from this point to that point, the height is sy, you get 16.06. Positive because initial point is here, final point is here, final is above initial, therefore positive. Okay, and then you have uy, which is fixed here, vy at maximum height is 0, then you have ay, negative 9.81, and it asks for time. So which equation is the most appropriate one? Okay, you actually can use two of them, but please choose the easiest one, so which is this one. Okay, and please don't choose this one because you don't have time in it. Okay, obviously, therefore use this. Please make sure you level. So vy, uy, ay, and t. Vy 0, uy is this one, okay, plus ay is negative 9.81, and then time. So you rearrange, you get 1.81 second, okay, time for it to reach maximum height. Okay, for part C, it asks you what is its velocity when it strikes the ground. Okay, so it asks you velocity when it strikes the ground. So velocity here, it asks you v here. Okay, so if I would like to draw velocity somewhere here, so we don't know whether it's x component or y component because it has angle. Okay, angle here. So we need to resolve it to x and y. Okay, x and y. So this is vx, so this is vy. So we need to find vx and vy. The way we need to find it is by using this equation. Okay, the magnitude of it. Okay, so vx, like I've mentioned previously, it's always equals to ux. Okay, and it's positive, therefore 42 cos 25. If you press your calculator, you get this value. Okay, but for vy, it's not straight away. Okay, we actually need to find it first. Therefore, these are the information that you have. Okay, I list down Suvat here as. So sy, we have a lot of information regarding sy. We have this value, we also have this value. So you can actually choose which height you want to use. For me, the easiest one is to choose this one. Why? Because if you choose this one, so the movement is from the maximum height to the point where it hits the ground. Okay, so we know at this point velocity is 0. So this point will be initial, this one will be final. So uy here is 0. Okay, this one will be vy, the final. Okay, uy, vy. Vy we want to find. Ay fixed, but you don't have any information regarding time. Okay, so the most appropriate equation that I'm going to use based on the information that I have here is the second one here. Okay, so vy equals to uy, ay, sy. So vy want to find, uy is equal to 0 because I chose sy to be this. Okay, 2, ay this one. Sy is negative 66.6 because initial is here, final is here. Therefore, final is below the initial, therefore I need to put negative there. Got it? So you simplify, you get vy equals to 36. That's why you get vy. Okay, I would like to emphasize, if you choose sy to be that, so this will be your uy, this will be your vy. But if you choose it to be here, this point will be your uy, this one will be your vy. So uy here will be equals to uy here. Okay, if you choose to use h equals to 50 here, so this will be your uy. Okay, got it? Okay, so you have Vx, you have Vy. Just plug in all the values in the equation here to get V, which is V from the ground, just before it hits the ground. Substitute. Okay, why I put negative here? If you look at the just sketching here, Vx is to the right, therefore it's positive. Vy is downward, so actually you need to put negative sign indicating that it is downward direction. Okay, therefore you get this value, which is 52.39. You also can find the direction by using this formula. So we get that. So that will be the theta here. Okay, for the last part, part D, determine the range of this object. Before I start on explaining this part, I would like to correct something. If you notice in the previous part, ABC, I wrote down G here. It should be A. Okay, positive should be A. Okay, so okay, proceed. So D, it asks you range. Range simply means this part. Okay, I'm just going to show you. Range is a horizontal distance. So range. So you should know automatically that you need to find Sx, or you can also label R. I'm going to label as X so that you can differentiate between X and Y. Okay. Okay, so we need to find Sx. So write down Suvat. S, you need to find. Ux, you have the value 42 cos 25. Vx will always equal to Ux. Ax is equal to 0 because it does not affect gravity. Gravity is on the y direction. But t, you don't have any information regarding that. Okay, so let's choose the most appropriate equation. So we need to find S. So obviously we need equation with S, therefore this one and this one. But look closely. If you choose this equation, A will become 0. Therefore this whole part will vanish. So you get V equals to U. So you cannot find S. Okay, for this part, this one vanish. Okay, so you need to you have S equals to UT, but you don't have time. So how are you going to do this question? Okay, you cannot get the answer. I only have this information. Therefore, you need to ask Y component for help. Okay, so let's start for Y first. Okay, this part, like I mentioned before, the S part, the value for S that you choose will determine where U and V is. Okay, so if you choose S to be 50 meter, it means that from here and here. Okay, since it asks for range, okay, means from the starting to the end, meaning the time also need to synchronize with that. So the time needs to be from here to there. So if you choose S equals to 50, then you are on the right track. But if you choose it to be 66.06, the time is from here to here. Therefore, if you use 66 here, down here is not the same as the time that we need to find for the range. Understand? Okay. So time It's from here to here, therefore we need to choose initial point here, final point here, therefore the SY is 50 meter. Okay. Negative because final position is below initial. Okay, got it? So U here, UY is 42 sine 25. Vy is here, which we get from the previous question, which is 36 meter per second. Okay, Ay is always also negative 9.81, and time. Okay, we need time here. Okay, therefore we're going to use y in order to find time. Choose equation. So the equation with time is the first and the third one. So you can actually use both. So these are the both working. So if you use the first one, so your Vy will equal to negative 36. Remember y is negative. Okay, you can check previous question, part C, y is negative. And then Uy is that one. Ay is that one, so you get time equals to 5.48 seconds. If you use this equation, Sy is equals to negative 50, Uy is that one, time, and then you get that. Okay, but if you use this, you will get two answers. One is 5.48 actually. Okay, and the other is negative 1.86. So how do you choose? Logic. Okay, you choose the positive one since time does not have negative value. Okay, so you see, if you choose any equation, you will get the same answer. Okay, so we have time now from here to here, but this we use y component. So use the same time for x component. Okay, we need to find Sx. So now we have time. Therefore, we can use this equation. Can we use this equation since we have time? No, because you don't have S here. Can we use this? We have explained before. If we use this, we cannot find S because A equals to 0. Okay, so you need to use this. S equals to ut plus half at squared. Please make sure you label x component. Okay, again time is scalar quantity, therefore no x and y. Okay, so just substitute. So ux is equal to this 0, time we find using the help of y component, so we get 28.6 meter. Okay, the answer here is probably a bit different from the scheme answer, but it's okay. It's just because of the decimal place use. So it's okay if you get a little bit different, but if you show the correct working, then you'll be fine. Okay, so that's all for question number 12.